Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness of fit test using the residuals and goodness of fit test and R with my stikpetR library. What I mean with residuals is that this is not comparing every possible pair of two categories. For that you could use a pairwise post-hoc test for which I have separate videos, but this one just looks at each category individually versus all other categories combined and their expected counts. Now I'm using Jupyter Lab with an R kernel, but this code should actually also work with, for example, R Studio. I do need a kernel, so let's run this command to see which version I'm at. I'm at 4.3, a little bit outdated, but should get the job done. And the only packages I have currently running are the ones that come with RStudio. Now, I'm not going to explain too much about how to interpret all the results and in which scenarios you should be using this test. It's just more about how to obtain the output. To show you an example, I have some data from the General Social Survey from 2012 adjusted for some example purposes. Once the data is loaded, that takes a little while, I can actually select just one nominal field. I'm going to be using MAR1, which is actually the marital status. And to give you a quick impression, I'll show you the frequency table, and for example 79 people indicated to be separated. Now, my library is not available on CRAN, so you will need to use DevTools and then install it from my GitHub. Once you've installed it, you can load it just as any other library. The function of interest is actually pH residual GoF, pH short for post-hoc, residuals or for goodness of fit, using goodness of fit, because you could also use binary test. For those I have a separate video and a separate function. So the function only takes the data actually as input, but there are some additional optional parameters. So the test, by default it's going to be using a Pearson test. It says here one sample, that should of course be goodness of fit test, so GOF. So you can choose between Pearson, Freeman, Tukey, and for each of these I actually have separate functions if you just want to perform that test on the data set itself. You can also specify expected counts if you have them, otherwise I will assume each category to be equal. You can choose various methods for multiple testing corrections. I think the default is using Bonferroni. Let's quickly take it for a spin without any additional parameters, just the data. What we get is the category, the observed count, the expected count, the chi-square test statistic. The degrees of freedom will always be 1 because we only have two categories, divorced versus all the others, married versus all the others, etc. -1 would give you the degrees of freedom. The p-value and the adjusted p-values, this is adjusted for multiple testing using Bonferroni in this case. If this value is below a predefined threshold, we would usually speak of a significant result. Usually this threshold is at 0.05. This e minus 0.4 means I need to divide this by 10 to the power of 4, so this is very small. So significant, significant. This one is actually 1, so not significant. And the other seems also significant. So only never married is not significantly different from the expected count. The minimum expected count is shown, the proportion or actually percentage of cells below 5. An expected count of 5 is shown in all these cases 0%, and a description of the test that was used. If you like, you can also specify those expected counts as mentioned earlier. I'll put them here in a data frame, so these were just some expected counts I came up with. And then I can use that as a parameter in my test, and that should now give me slightly different results as you can see, but now it's actually using, as you can see over here, those expected counts that I predefined. Alright, I hope this video was helpful and thank you for watching.